Okay, welcome everybody. Um, Welcome to our Textiles Talks. My name is Khadija Aziz and my pronouns are she and her. I'm a member of the membership committee at the Surface Design Association, which is a membership nonprofit focused on contemporary fiber and textile art. I'm delighted to welcome you to this week's Textile Talks, Crafting with Technology. Textile Talks webinars are brought to you by the International Quilt Museum, the Modern Quilt Guild, Quilt Alliance, San Jose Museum of Quilts and Textiles, Studio Art Quilt Associates, and Surface Design Association. I wish to acknowledge that I am physically located in the ancestral and traditional territories of the Anishinaabe Mississaugas, adjacent to the Mississaugas of Scugog Island First Nation, and in the territory covered by the Williams Treaty, now known as Ajax, Ontario, by settlers and immigrants. These places are and will continue to be home to Indigenous peoples. By acknowledging the traditional territories that I am engaged in my daily life, I wish to reflect on my personal relationships with Indigenous international relations, which include humans, animals, plants, earth, water, and air. This territorial acknowledgement was created in conversation with Indigenous and non-Indigenous peoples through verbal dialogues. Before we begin our textile talks today, we have a few housekeeping announcements. This is a webinar, so your screens and mics are not showing. We welcome questions, which we hope to answer at the end of all of the artist presentations. Please submit your questions in the Q&A box located at the bottom of your screens if you're using a laptop, or sometimes if you're using a phone or a tablet, it's on the top of your screen. We are honored to bring you free and inspiring Textile Talks programming. We respectfully ask you to be courteous as you engage with speakers, moderators, and other participants. Your chat comments can be seen by everybody. Please use the Q&A for questions, chat box for greeting others, and survey for commentary or ways we can improve. If you prefer not to see notifications from the chat, you can click on the chat button to toggle them on or off. This webinar would not be possible without the support of our sponsors, which are Moda Fabrics and Supplies, Quilting Daily, Orifil, eQuilter.com, Artistic Artifacts, Clover, Empty Spool Seminars, Mistifuse, 9 Patch Fabrics, Quilt Mania, Schiffer Publishing, Thai Silks, and thequiltshow.com. Please remember them when making your next purchases. Overview of today's presentation called Crafting with Technology. How does the collaboration between hand and machine contribute to the potential of crafts? What does it mean to make the digital tangible? This webinar will introduce textile artists and designers who use technology and digital tools to investigate modes of communication, materiality, and traditional craft techniques. Our first presenter today is Dr. Nithikul Nimkulrat. Dr. Nithikul Nimkulrat intertwines research with textile practice, focusing on experiential knowledge and craft processes. Before joining OCAD University as Associate Professor in Material Art and Design and currently Acting Chair of the program, Nithikul taught at the Estonian Academy of Arts in Estonia, Loughborough University in UK, and Aalto University in Finland, where she earned a doctorate in 2009. She is the main editor of Crafting Textiles in the Digital Age, published by Bloomsbury in 2016, and co-designs journal special issue on experiential knowledge and collaboration, published in 2020. Welcome, Nithikul, and let's hear from you first.
Thanks, Khadija, for your introduction, and thanks for asking me to speak today about a project that you listened to it like 2 years ago, I guess. And hi, my audience, thanks for being here from so many places around the world. So I'm going to start by sharing my screen so you can see my slide. Okay, I hope you're seeing it. Okay, oops, sorry. Okay, this talk, Handcrafting Through Digital Means, is about a 2.5-month project during my design residency at Emily Carr University of Art and Design in 2017 before I joined OCAD. First, I would like you to take a look at this short video. Oh, sorry, it's interrupted. bit about my background, I've worked extensively in textiles, mixing experimental and traditional forms of hand knotting to produce three-dimensional artifacts. This project started with this question: how can handcrafted artifact be translated into a digitally fabricated artifact? In order to translate handcrafted objects using digital tools, of course, an artifact was needed. So I handcrafted a small artifact using paper string for use for experimentation with digital tools available in the digital fabrication lab at Emily Corr. It was a replica of my previously created work called the coffee cup 10 years prior. The first approach I took was 3D scanning. It was the most straightforward approach, and I thought that, oh, my project would finish within a week, because first the scans of the cup show the allied quality, resembling the characteristic of paper string and the handcraft very nicely. But the problem was that the files of the scans were too large to process effectively in CAD, causing computer crashes. So basically on that day, none of the computer in the lab worked because of me. So I returned to a very fundamental technique of freehand drawing. So I did freehand drawing on a photograph of the knotted cup, and then utilize a section of it and import it to a 3D modeling program. In this case, I used Cinema 4D. With this approach, I could produce a simplified model that avoided the unmanageable amount of data. And here is the model of a 3D-dimensional array of one section of the knotted pattern that could achieve a resemblance of the knotted cup in the beginning. And this is how my workstation looked like. I use a stylus on a Wacom tablet. Handling a digital tool to interact with the CAD program resonates with Clark and Chalmers's extended my thesis, the idea that the material, that the mind is not necessarily contained within the brain or physical body, but can extend to elements of the environment. In this case, the mind extends to the virtual software and the hand to the digital tool. After completing the CAD model, I moved to 3D printing it. And as a novice in digital fabrication at that time, I would like to better understand the capacity of the materials and the tools in relation to the delicate cup form. So I started by setting the details of the CAD model as small as 0.4 millimeter and use only partial support material. The printer managed to print the entire model, but the print couldn't retain the cup form. The next step was to find the thickness suitable to the capacity of the machine while preserving the characteristics of knots, likeness of strings, and fidelity of hand knotting. The model thickness was modified and test printed. Once the thickness of 0.8 millimeter was decided, it was used for further printing using various types of PLA composite materials, including wood and copper. In the slide, you can see two wood prints, one unsuccessful and one successful. Several iterations of setting parameters of the printing slicing software were changed to explore the material's properties. For example, in the case of wood composite, the speed for printing it was gradually increased to enhance the flow of the filament due to the material's fibrous property that caused clogging to the extruder nozzle. Printing the 3D model of the cup in various composite filament allow for a detailed comparison of the printed outcome. As you can see in the slide from left, copper, wood, and biodegradable PLA in black and white. As Sennett points out, by making something happen more than once, we have an object to ponder. Variations in that conjuring act permit exploration of sameness and difference. Practicing become a narrative rather than mere digital repetition. At that point, even though the 3D printed cups could capture the likeness of the original hand knotted cup, I felt that the physical characteristics of knots, including the continuity, flexibility, and bendability of knots, are things that string does well, were missing from the prints. So I decided that I wanted to continue this project to represent the nature of knots more clearly. And with this aim, I decided to create a new CAD model of flexible loose knots. So I returned to the same method, but faced a difficulty of virtually knotting on a 2D screen that couldn't depict sufficiently the positions of strands and the interlacing of them that construct knots. So seeing me struggling with this, my human collaborator suggested me to go into VR space and draw there. So I drew knot structures in a 3D VR space, imitating a gestural manner to real-world hand knotting of string. Drawing in VR recall my hands-on experience and relational understanding of position of strands in three-dimensional space that I have with hand knotting. So I found a solution for making a CAD model of a section of loose knots as I intended. So you can see in the model here, all the strands are interlaced, but not touching one another. The next challenge was to print it. It's just because when strands are interlaced, there are a lot of steep angles, and the printing nozzle irritated a previously printed area with a steep angle, and that caused it to shift from its original position on the support material, resulting in the detachment of the print of the next printed layer. And once the print was taken from the printer with the support material removed, as you can see in the black print, one part of it was missing. So I adjust the density of the supporting material, the printing speed, as well as the model itself to achieve a full print, as you can see in the white print here. The next step was a natural one, just to create multiple sectional loose knots. It was really easy. And at this point, I had 1 week left, so I was thinking what to do next. And in this digital fabrication lab, there was 3D powder printing technology that at first I couldn't relate my practice to it. But after accumulating my skill and knowledge in 3D modeling and printing, I saw this as a new opportunity for giving function to my cup. I need to tell you a little bit that even I'm a textile practitioner by profession, I gained in my first degree in industrial design and understanding of principles of mold making for prototyping and ceramics. So I combine knowledge that I gained 20 years ago with recently gained knowledge and construct a two-piece mold for slip casting virtually. And in the right image, you can see the mold was being taken from the printer. And after that, the mold was sprayed with water and let dry to increase plasticity. After that, a porcelain slip was cast in it. The cast piece had to sit in the mold quite much longer than if it were cast in traditional plaster mold because of the higher density of this material. this is the cast cup, which had a unique texture that was the imprint of how the mold was constructed with powder layer by layer. This is also a kind of the craft of the machine that even the hand, like human hand, cannot imitate it. And this diagram, just to summarize this, the acts of hybridization that require translation, the flow of translation from analog language to digital language provides new opportunities and understandings way of gestural maneuver. Like from the start, with analog gesture of hand knotting using paper string, the gesture was translated via digital process and digital tools into 3D model, and also translated via material into 3D printed artifact. And in case of 3D printed mold, the gesture was translated again via analog process through slip casting to create a cast cup. So that's all from this project. So these are, you know, I not only collaborated with the machines, but I have human collaborators as well. So these are people who helped me along the way. And these are references that I cite in my presentation. And this is an article that I published in December last year in Craft Research about this project. So that's all. Thanks for your attention. So I'm going to stop sharing my screen.
Thank you, Nithikul. Yeah, I heard this presentation from you 2 years ago, and it's something I keep thinking about even now. And your presentation or your project total, it's a great example of all like your problem-solving journey as you translate traditional materials and traditional techniques into the digital realm. Thank you so much. Our next presenter is Olivia Valentine from Des Moines, Iowa. Olivia Valentine is a visual artist working in textile construction, drawing, and photography, as well as collaborative projects that span a variety of media and disciplines. Recent exhibitions include a solo exhibition at the Des Moines Art Center, the Museum of Arts and Design in New York, Heaven Gallery in Chicago, and the Danish Royal Academy in Copenhagen. She is the recipient of a Fulbright Fellowship for Installation Art in Turkey, the Branford Elliott Award for Excellence in Fiber Arts, and a 2020 Iowa Artist Fellow. Welcome, Olivia. Thank you for being here. Olivia, you are on mute right now. Okay.
Yeah, thank you, Khadija. I realized that as I was pressing my screen share. Thank you so much for the introduction, and I'm really thrilled to be here today and to show this work. Thank you also to Astrid and the Surface Design Association for inviting me today. So I'm Olivia Valentine, and it's really exciting to be here today as part of this panel. Today, I'm going to be presenting my long-term project Between Systems and Grounds, which is now a 5-year collaboration with various different outputs with the sound artist and composer Paul Matheson. As
Olivia,
Khadija said, I'm
really
yes.
sorry to interrupt, but right now we're seeing your interview. I think you need to switch to the other monitor.
Oh no, yeah. Oh, I'm so sorry. Thank you. That's not great. I thought we were going to get over that. Thank you, Lucy. I appreciate that. Let me try this again. And how about that?
Yes, looks great. Thank you.
Super. Sorry about that. So Between Systems and Grounds is a collaborative durational performance and installation project that creates a feedback loop between textile construction processes, such as the bobbin lace shown here, and feedback-based electronic music, which is Paula's area of expertise, or one of her areas of expertise as both a composer and sound artist and musician. So both of these are generative systems that are otherwise pretty different in their approach. This project came out of a desire to connect these two systems through time, shared space, and a system of sonic and visual exchanges designed to produce an accumulation of interrelated sound and textile artifacts. The nature of both the sound and textile production is improvisational in approach and responds to atmospheric conditions and sounds, as well as ongoing dialogue between these two systems and ourselves as makers. Here, bobbin lace is shown. This was the origin of the project, which is now also expanded to include an AVL CompuDavi loom that I'll show a little bit later. Here are two components of the project that we have chosen to work with that have become interrelated through our use of them and remain in the project, even though the project has expanded considerably over the past 5 years. On the left, we have a small sample of the rose ground fabric that I'm using as a bobbin lace construction technique. I selected it for its relationship both to the grid and also to a binary on-off system, right? Because we have things that are filled and things that are open. Early on in the project, Paula acquired this 6-channel matrix switcher, which we then directly aligned to the fabric. Here we have the possibilities for 6 different switches to be on and off. So I made a fabric that is 12 units wide. So those are two of the sort of foundations of the project. I will start here now. We started working together. We met in 2015 and then started working together in 2016 through a series of residencies. Here, a sort of cumulative performance at the Acre residency in Steuben, Wisconsin. One of the foundations of our practice together is that it takes time. We both work in time-based media. I consider textiles to be essentially a time-based media. And so trying to figure out how to work with that together in different ways, and then also in representation and in documentation. So here you'll see a video of an approximately 3-hour performance on July 22nd, 2016. The video is a full duration of those 3 hours, and then the audio that you're here is a compression of 1 hour of that time. So with this project, there are multiple modes of dialogue and feedback between these two systems. There you saw us sharing some space and time together. The project was quite small. I will point out, sort of how short the lace fabric was at that point. There are a few different ways that the information and the production that we're doing feed back and forth to each other over the course of working together. So I'll go through these in the following slides, but this is all of them together in one place. So one of the first things that happen is as we are playing together, there are slow and changing ideas to this, what we're hearing in the room together. Paula is making shifts. We start usually with the bobbin lace project with the sound of my working. It gets amplified, fed back into a system, and slowly changes over time. So with each one of these sonic changes, I instigate either a change in patterning or a run or a hole in the bobbin lace fabric that I'm making. These sort of ricochet throughout the fabric. And so that's one way that things feed back. Here you can see some of those changes happening, right? So we have some runs across the screen here, and then some different patterns happening within the bobbin lace, within that rose ground system that I had selected to work with. Here I will play, I believe, just a very short sample. Actually, I may have taken it out. This is just a short sample of the sound of what it sounds like to be in the room with us. You'll also notice some external noises to the project. So there you could hear a bit of my working the bobbins on the foam core ground. There's also some thunder and lightning and natural sounds, as well as the tones which are developed from feedback that's generated in the room, giving us the resonant frequency of the spaces that we're working in. So another thing that's happening while we're working together that's a method of feedback between the two systems is that every time that my bobbins are striking the work surface, there's a contact mic that's embedded in the surface that I'm working on, and that sends a small signal to Paula and her system to make what we call a micro recording. It's a very short recording of what happens to be happening in the room at that moment. Those get stacked on top of each other, and so you heard an example of that in the first video that I showed. So it sounds very different than actually that slower sound that I just showed you, but it's comprised of all of that just in micro chunks that are stacked on top of each other. It usually also ends up that about an hour of work ends up maybe to be a minute, 30 seconds to 2 minutes of sound in that way. Those bobbin strikes hitting the contact mic, hitting the work surface also are simultaneously making a data stream. Here you can see some of that data along the bottom of the screen. It's essentially a 5-point moving average, or a 5-point average of the time between movements for me, and it varies pretty dramatically, which is why we use the average. But then I am then bringing that data back into the textile pattern itself, but on a very slow basis. It's, you know, I'll make 100 points per session, and then maybe I'll be able to work 5, 10 during a work session. And so we've accumulated vast amounts of data on this project in the meantime, which has led to some other outputs as well. And so here you can see a little bit of the data then coming back into the bobbin lace pattern. And then ultimately we also have a second way of showing this work, which is that actually the system itself works as a playback device so that the work can stand alone without us in installation. Here you can see a front view of this system. I will also note here that the entire workspace is made out of foam core, which makes it easily transportable. We've been able to actually perform this project in a number of different places. And it breaks down and sets up easily, and I can change and modify the parts as we go. Another output of the project was a recording done. It was a series of recordings actually done in 2016, but we released them as an album on audio cassette and also digital download through Carrier Records in 2018. And this is just a still image from the performance that we did in celebration of releasing that audio cassette, where we for the first time also brought in additional collaborators, both visual artists and musical artists, to perform with us in I think it was a 3-hour event celebrating the launch of the album here at the Remains Lighting Factory in Brooklyn, New York. And then I also just wanted to show at least a little bit of this last video. This was our last performance in February 29th, 2020. I think many of us will understand that as being a moment right before the pandemic really hit home in North America. So this was our last public performance. It was at an international conference at the University of Chicago called Chime Fest. I'll play just a few moments of this so you can hear some of the changes that we've made to the audio over the course of this project. Paula has brought in additional sort of methods to her music making in this. And so this is the real time, what you would have heard in the room for audio, and then the video is a stop motion animation. So to keep this brief, I will move on from that, but I will note also that our website has extensive documentation on all of our projects, so you're more than welcome to see any number of videos and listen to audio there, which I believe has already been posted in the chat and will get circulated again. So in the spring of 2017, I think it was 2017, I was able to acquire a AVL CompuDavi loom with both this project and a couple other studio projects in mind. I was excited for this because it is this place between hand weaving and digital technology that seemed like the right thing for me in my practice. So here, Paula and I are working in the studio here in Des Moines in March of 2019, trying to figure out how to bring the loom into our system and her working process to the loom. We started out actually using the loom as a way of visualizing and making physical all of the data that we had accumulated over the course of the project to date, here 3 years in. And so I realized that maybe weaving this data might be a way to start. And so we sat together and I started using woven data, or I started weaving the data. Paula was actually using samples from previous sessions with the sound, and we started figuring out how to expand our system. I made several decisions early on with the textile design, thinking about that. I decided to work with what's called an overshot pattern, specifically here, as shown here with monk's belt, as a way to think about how we might get Paula more involved in the textile design that I was making on the fly. I was excited about this for its AXBX patterning and the ability to just have this either tabby or twill woven ground and then have these floats that go over top. These would allow us to really be improvisatory in thinking about the patterning while also having little chance for structural failure. And so here's a short video of one of our first sessions playing together. This will be the last video I'll show today, but you'll be able to hear a really different set of sounds that we're working with. And I'll talk a little bit more about how those sounds are developing in the next slides. So I think Paula and I both felt very lucky in many ways that at the beginning of the pandemic, we had already started working with the loom. There was an additional session that we did together in January of 2020, starting to develop some software for the program that made it possible for us to continue. So in the summer of 2020, we started thinking, how could we continue this project, which was so founded in sharing time and space together across the space of the internet. And so this is just a little diagram that I made as we were having these discussions about how we might interrelate our systems. And so that gets distilled into this. These are the processes and feedback loops that we're using with the loom now. And so I'll go through these with a couple of visuals. So here, a visualization just of Paula being elsewhere. And so now I'm actually generating feedback in my studio. This resonates, it gives the resonant tone of the space that I'm in and some of its subtleties. That gets sent to Paula in her studio in Connecticut over an audio streaming software called CleanFeed. Paula is then working with that sound. It gets sent back to us over an internet radio station that we have. It's actually active 24/7 with archival footage, and then we use it when we're actively working and performing together as well. That is then brought into my studio where I have a custom software that Paula and I developed together, which is generating WIF files or Weaver's interchange format files from the sounds in the room. And those are we call it the Wiffer Maker, is shown here. And you'll see on the right sort of how many files we're making. It makes one every few minutes. And then each one has maybe, like, depending on the fabric that we're working with, anywhere from 16 to 64 weaving shots. And just to get a further sense of what that looks like, on the left here, we have the text of the WIF file. So there's a tie-up and the treadling. The treadling is the data that's getting given, or that we're distilling from the sounds in the room. Here with the fabric that I was developing last summer. And then as a challenge this year, I also decided to do some double weave in a tube. And so this is the warp that I've been working with for the past few months. And then ultimately, we also have a contact mic that's attached to my loom. This gives data back to Paula that instead of directly impacting the fabric I'm making this time, or creating these small recordings, the micro recordings, this time I'm actually actively engaging with the pitch and the tone of the sounds that are coming out of Paula's system. And so you could hear some of that in the recording that I showed. Here are two fabric samples from last summer. On the right, over the course of 5 days of performance, and then on the left, one of these tubes that I was looking at developing. We've also been able to do a series of performances on the internet over the past year, which has been certainly a new experience for me. These are some of the relevant links for the project, including an exhibition that we'll be doing here in Des Moines, but which will also have a virtual presence in September, Loom Room Harp, as well as Paula and I's individual websites. And this project certainly has had the support from a number of institutions, residencies, and individuals over the course of the 5 years that we've been doing it. Thank you so much for listening.
Thank you, Olivia. Thanks for taking us in depth to your practice, your textile knitting practice, and also for helping us kind of visualize or imagine the possibilities of the sound. So thank you. With our last but not least presenter today is Lee Jones from Ottawa, Ontario. Lee Jones is a PhD student at the Creative Interactions Lab at Carleton University. In her research, she uses participatory design and creates easy-to-use toolkits so that individuals can build prototypes and have a say in the direction of their own technologies. In her thesis research, she is developing toolkits for prototyping wearable e-textiles. She has taught undergraduate and graduate courses on wearable technology and loves running e-textile workshops in makerspaces, art galleries, and community organizations under the name Electro Stitches. Welcome, Lee.
Thanks so much. I'm so excited to talk about my favorite topic in the world, e-textiles. I'll just share my screen. Okay. So when we think about technology, we often think about it as something that we buy rather than something that we can make. But today I'm going to talk about how we can use e-textiles or electronic textiles to enable individuals to make their own technologies to suit their own needs. So I'm an e-textile designer who works in the field of human-computer interaction, which, like the name suggests, is a study of how people interact with computers. My specific focus within that is DIY and maker toolkits. So I look at technologies that people can make for themselves at home. So instead of prototyping with expensive machines, I focus on tools that are more accessible. So before we get into my e-textile projects, I'll explain a bit about what e-textiles are and what they can do. And this will hopefully give folks a better understanding of why e-textiles are such an exciting area for artistic expression and interactive textile artworks. So e-textiles is short for electronic textiles, And what that means is that we can use the conductive properties of textiles that are already available, such as stainless steel, silver, and gold threads, and then connect those threads and fibers to really small computers. So the one pictured here is called the Lily Pad, and it's a sewable microcontroller, which is a small computer that we can program. And there are a lot of educational kits with the Lily Pad. So these concepts aren't just for engineers, they're increasingly being used for elementary school education. So the conductive fibers and microcontrollers are some of the basic materials, but what we can do with them is actually really broad. So we can make textiles that sense changes. So for example, an e-textile would be able to know that I'm excited and doing a presentation right now. Using certain dyes, we can make textiles that change color to reveal certain patterns or hidden messages. Like the textile in the background that was a solid orange and then changed to these white stripes. We can make textiles that change or remember shapes. So for example, you could imagine like a long sleeve shirt that automatically goes to a short sleeve shirt. And finally, we can make sound or vibration. So here are some examples of some soft speakers that I worked on with Sarah Nabil and Audrey Girard at the Creative Interactions Lab. So these are completely soft textile speakers that could, for example, play music or like give you a nice back massage. And by making them with an embroidery machine, it also enables individuals to make their own speaker designs. So all the individuals that we worked with designed their own to suit their own context and their own imagined ideas. And that's really the coolest part about textiles, is that they're everywhere. So they're in our clothes, in our homes, soft furnishings, soft objects. And we can embed these sensing and actuating properties in a way that they're invisible, but they also can support us when we need them. So that's some of the technical possibilities. But what I find so exciting about e-textiles is that they're a hybrid craft, which means that using textile craft techniques, we can work with these raw materials to make things that are both interactive as well as expressive. So here are a few examples of techniques such as spinning, weaving, and felting. And all these hybrids, they leverage the immense technical knowledge that fiber artists already have. And they also don't look like technology. So on the left is a bunch of DIY sensors like tilt sensors, push buttons, stroke sensors, and squishy pom-poms. And I made these when I was first starting out based on tutorials online. And then on the right is a woven material that can sense when you're stretching it. So for example, if you pulled on the material, it could respond to you. But what I love the most about e-textiles is that these DIY techniques and all these DIY techniques is that they're hackable and editable. So for example, in this case, I used a punch needle to make a touch sensitive rug sample. And then by pulling the threads out, I could redo the design to make something new. And for this punch needle project, I gathered tools that could be punched in to make unique designs, while also helping beginners learn about e-textiles and electronics. So while someone is learning to make a circuit, they're also being creative and expressive in their design. Punch needle also has the unique feature compared to some other techniques in that we can pull out threads really easily and redo stitches. And this is also great for electronics and for beginners because they can make mistakes with their circuit, realize something's wrong, and then really easily fix it. And it also helps with accessibility. So most DIY e-textile toolkits are made for hand sewing with a needle and thread. But a needle is a difficult tool to use and adapt because it's so small, and it also needs to stay small in order to go through the fabric. But what's great about using a punch needle instead is that it enables individuals to hold it in a wide variety of ways, such as like pen or pencil grip, fisted grasp, or with adaptive cuffs and grips. And that's what's so great about textile technologies, is that even if one technique, like a fine needle, isn't accessible, there are so many other techniques that can be used. So individuals can use a wide variety of techniques to make their own soft and interactive computers. And in my art practice, I'm interested in DIY methods, particularly for how they enable individuals to imagine and come up with their own concepts for what interactive textiles they would want in their life. And not only that, but once they come up with an idea, they can actually make it and imagine what it would be like to live with this thing. The first step I do in workshops is sketching out ideas and getting creative. So for my research, I developed a deck called Wearable Crazy Eights, and you can use it at wearablecrazy8s.com. And what it does is it combines rapid sketching with ideation cards that include garments, situations, and different adverbs to describe the interaction. So for example, someone could pick like a skirt for walking, surprisingly, and then the individual quickly sketches out the idea or writes a short scenario. So in this case, someone made a skirt with stripes that make music when touched. So you can see how their idea was inspired by the cards, but also reflects their own design choices. And they can then try to do 8 different sketches in 8 minutes. And the next step is then building the concept. So along with the punch needle, one of my earliest projects was wearable bits, which were these e-textile puzzle pieces that folks could then plug together. So after sketching out an idea, they could actually embody the concept as well and try it on. And they came up with really wonderful ideas. So one of my favorites is a 1920s flapper dress where the fringe is made of these stroke sensors, and then the dress makes music as you move. So when you think of the commercial wearables that like measure all the data from your body, none of the ideas that came up from these workshops really reflected those. So people really wanted textiles that were expressive or for comfort rather than for tracking. During the pandemic, I've been looking into DIY practices for how individuals could update their own clothes and textiles with e-textiles. So instead of making an e-textile garment from scratch, individuals could add e-textiles to items they already own through decorative stitches. This started with interviews with visual mending educators to understand like how they teach visual mending to others. So based on the insights from the interviews with visual menders, I've been developing e-textile mending samplers for a new type of like hybrid mending practice where we could augment the textiles we already own with new interactive possibilities. So the concept of using a stitch sampler instead of having other tutorial formats came from looking at the samplers that the visual mending educators had. So all of them had samplers that showed the process of making a mend. So I developed a stitch sampler for e-darning, where at the top it shows the darning steps, and then at the bottom there are 3 different examples of components that you can make. So here's a close-up of the steps for making a darning mend: making a warp, the vertical stitches, then the weft, the horizontal stitches, and then tying the threads to the back. And for these darns, I've used a darning loom, which holds the warp stitches, and then you can flip it to bring the opposing threads to the front. And then by putting the weft through, you can make a little patch. So here's a close-up of the bottom example darns with different functionalities. So the first one, stretch, it measures when you're pulling on something. The second one, the power pocket, is a little pocket for a battery to power up your electronics. And the third one has capacitive touch areas, so it can recognize when you're touching it. And this is why I love working with textile designers and crafters so much, because so many of the issues that we have with e-textiles, such as how to teach individuals how to stitch, how to separate threads, not make them touch, thinking about sustainability, textile designers have so much of the technical knowledge for how to solve these problems and how we can use different techniques for specific issues. And also by using these craft techniques for DIY toolkits, we can encourage individuals to design their own technologies instead of just buying from what is available. So as technologies come into our home, they're going to need to look and feel like the things that fit within that space. And if we look around our homes at what's there, increasingly those technologies will be textiles. But what I'm really excited about is how e-textiles enable us to make technologies for ourselves. So you'll have the ability to customize your technologies to suit your own needs. And also, if you make something for yourself, it also means that you know how to fix it, how to update it. And this has sustainability implications as well. So overall, I can't wait to see what folks make with these crafting and maker technologies. And feel free to get in touch by email or any of the other methods for any questions. Thanks.
Thank you. Thank you, Lee. Okay, so we'll get to questions if all artists can turn on their screens. And I have a question, and then we have some questions in the Q&A. If other folks have questions, please write them in the Q&A so we can all see them in that one place. I'll begin with my question, which is, and some of you have kind of implied this in your presentations. My question is, do you consider your digital tools or technologies that you use as your collaborators or assistants that help you achieve your craft goals? Anybody can go. Okay.
So for me, what's so interesting, because my background is in tangible technologies. So what's been so interesting for me is just learning of all the affordances of these different techniques. So for example, think about like the punch needle and how it suddenly enables you to like take things out. So that's what's really interesting, is like they each have their own limitations and possibilities. So I feel like that's the collaboration. It's like figuring out what's possible with each of these techniques. And then when I think of like e-textiles, what can they do in that context? For example, like helping beginners pull stuff out and put it back in, etc.
Thank you. Olivia, what do you think?
I mean, I guess I've been thinking about this because I guess the project that I've shown, I already have a collaborator, right? I have a human collaborator. And then we also have this huge arsenal of different technologies, both analog and digital, that we're using. And so I guess in some ways, I certainly don't necessarily differentiate between analog technologies and digital technologies, except for the thinking about like this change with the pandemic, that sort of all of the digital technologies that were actually allowed us to continue sharing space. So in that way, it almost is, it's spatial, maybe more so than a collaboration. Like it allows for space for us to do the digital technology, to do what we had been doing in real time, in real space, but we've been able to continue it in a digital space, which I think is a really interesting flip maybe on that. But as far as the tools that we have, some things we do are very digital, some things, and this applies to Paula as well. Some of her tools are very much analog tools that are then getting manipulated by digital technology and vice versa. I don't know if that gets to an answer, but I think it's a good question.
And for me, if I have to choose between digital tools being collaborators or being assistants in this particular project that I talk about, obviously they are collaborators. But I would say, like I already mentioned in my presentation, that they are more like the extension of my hand. They are more than collaborators.
Yeah, thank you. Now I'll go over audience questions. Darcy Berg is asking, is it possible to make e-textiles that are motion sensitive? For instance, as you walk by, the textile actually says something to you?
Yeah, for sure. Like there's so many ways that we can measure an individual's movement. So for example, you could have it where like some kind of movement you do closes a circuit, like when I put my arm this way, that turns something on. Or you can have things that measure like movement or tilt, or your own, like whenever you touch a certain area. So there's so much that's possible. And I am more than happy to like answer any email questions about specifics.
Okay, thank you. I think this question is for Nithikul from Lee McLean. Regarding 3D modeling of the knotting, what do you project as potential uses of your explorations?
Well, they can turn into many different functional objects. It could turn into a vessel, it could turn into variables. It's just about playing it into certain forms. So it can be anything. That would be my answer.
Thank you. We have a question for Olivia from Betsy Stark. I am a musician and I sew, but I think of these activities as being separate. How did you get the idea of creating music from textile creation?
That's a really good question. I think for me, when I first started making bobbin lace, I was really attuned to the sonic properties of it, in part because I was working with sort of weird bobbins, weird things as bobbins. But when Paula and I met, I'd actually been looking for somebody to work with to do sound work for a long time. And when I met her, we have a lot of overlapping interests that I didn't go into too much today, but some of those are about pattern and the way it falls apart, as well as thinking about time in certain ways. So for me, both music and textiles are time-based practices. And so that was the starting place. We otherwise knew that they were maybe quite different, but to see if we could get them to work together was really, part of that beginning. And it's been pretty interesting to continue through. I hope that helps. But maybe try bring some sewing into your music or vice versa.
Mm-hmm. Thank you. I'm not sure who this question is for, but do you see any medical benefits for users? It might be for Lee or Nithikul.
Well, I think that's interesting. That's definitely something that gets brought up a lot for e-textiles. But in terms of like with what I'm really excited about with e-textiles, the fact you can design something for yourself. So for example, have things that are for your own comfort, like for example, provide heat or provide back massages or things like that. So there's so much that you could design for yourself without needing, medical expertise or anything like that, just for your own comfort. Yeah, there's so many possibilities.
Thank you. It is 3 o'clock. We'll just answer a few more questions and then we'll wrap it up. This question is for Nithikul from Laura Salami. Nithikul, are you afraid that all of this 3D printing of art will get so successful that we'll lose the ability to learn original forms of art?
Actually, don't think so. I think as a craft person, I approach these tools differently. If I would have learned the tools without any craft background, of course, that would result in different things. So I don't think that these technology actually damage any artistic creativity or skills at all. It's just a different ways of practice, actually. But as a craft practitioner, you see everything in more detail, I would say.
Mm-hmm. Thank you. Okay. Okay. I think we are able to, there are a lot of questions coming in, but I think we'll wrap it up now. Thank you everybody for asking those questions. Please do reach out or please do follow all artists on social media. Perhaps that way you can learn more about their practices. I'll just say thank you again for asking the questions and for attending, everybody. Thank you to our sponsors and to SAQA for hosting us. The recording will be available on YouTube in the next week for folks who are asking or for folks who may have missed the talk. Next Wednesday's Textile Talks. Next Wednesday's Textile Talks is Conversations with the Artists, Primal Forces Earth, presented by SAQA, which is the Studio Art Quilt Associates. Thank you so much for all the artists and